Hello, everyone, and welcome back to Creating in Fortnite. I am your host, Dan Hutnick, standing in for the lovely Shane, who unfortunately couldn't be here today. But we're going to go ahead and talk about physics with the people who know them best. And I'm going to go ahead and let them introduce themselves. So let's start with you, Jay. How you doing?
Hi, I'm great. Thanks, Dan. Hi, everyone. My name is Jay. I'm a product management director at Epic, and I help to bring physics, general physics, to UEFN. I have been making games for over 22 years. I love making games big and small, and I just ensure that we hear all your feedback and that UEFN has the capacity to make the games that you want to make.
Perfect, perfect. And next, Matt.
Hello, my name is Matt Amar. I'm a gameplay engineer at Epic. I am Halcyon Knight in the forums and other social media places. But yeah, I've been working with Jay to try to provide a great physics experience for UEFN developers.
Perfect. And then last but certainly not least, Noah, go ahead.
Hi, I'm Noah. I'm NoahUEFN. Some of you might know me out of my name. And I'm a verse developer. And today I'm going to show all of you how I built a verse mechanic with physics that is pretty cool. All of you will enjoy it. So have a look and enjoy the stream.
Perfect. Perfect, perfect. So, Jay, for people who aren't aware, what is physics? What are we going to be talking about here today?
Well, what we brought is generalized physics to UEFN, so you can take any Fortnite prop and add physical simulation to that. Um, One of the things that you can do when you enable physics in the editor is that you'll be able to change from the normal Fortnite character to what's called a physically based one. This is a physically based character that moves via forces instead of directly with animation. And because of that, it can interact with physics props. It can push those props around. It can shoot those props. It can hit them with a pickaxe. It can jump on top of them. And then, additionally, when you enable physics, those physics props will interact with certain devices that we've updated. So some of the things you can do is we upgraded all the devices that apply physics, such as that apply forces, such as the air vent, the D launcher, the pinball bumper. We've also upgraded devices such as the trigger, the volume device, so you can make physics-based gameplay.
Perfect. Perfect. Well, I know we have a lot of cover here. If you're all ready to go in and start showing some stuff off, I'm happy to jump in.
Absolutely. Let's switch to the editor.
Perfect.
All right. So you could take any project you have and upgrade it to physics and UEFN. You just want to go to your project settings up here, and then you're going to go to the project, scroll to the bottom, and then you'll see the physics beta. And once you get beta access and you turn it on, just give it a moment, and then physics will be on. That's all you have to do in your project. To take an actual prop and turn on physics on it, just populate any prop. So any prop that you find here in your drawer, and you're going to go to add. And I'm going to go and type physics in here or physics. That adds the physics component. You want to enable simulation. And once you enable simulation, you get the physics options. The physics options here are the ability to override mass. So mass, how much stuff is in the thing, is calculated for you. But if you want to override it, you can check this box and set it to whatever number you want. So you can make it lighter, heavier, and this is in kilograms. You can enable and disable gravity. So if you disable gravity and you strike this box, it'll go flying away. Starting awake, what that does is you can put the box in the air and it won't do anything until a physics force acts on it. Once it acts on it, then it'll begin simulating. Linear damping. This is like drag. This is if you push something, this is how much sort of friction it has to slow it down and bring it back to a stop. So you can make something frictionless or have it be very, very hard to move. Angular damping is the same thing, but rotation. You'll be able to, as an object rotates, how soon does it stop rotating? The impulse and hit multiplier allows you to figure out on the pickaxe, on a weapon hit, how much force is applied to this. You can multiply that up and down as you see content for your game. Then we also have constraints. I'm going to go over to the slap juice sign real quick. So you can constrain an object from moving around. And I'll demonstrate this in the game in a moment. So I've locked the rotation of this. I don't want it to spin about its left axis or forward, and that's going to be the left axis and forward are here, the red and the blue, but I want it to spin around the up, the green. I also want to lock its translation. So if I click lock translation, left, up, forward, what this means is it's stuck in space. It will not move. So I mentioned that maybe use devices to make physics gameplay, and that physics, those devices, once you enable the physics, will be under devices, beta, physics. These are all the devices that we have upgraded for physics. If it's not in here, it may not be entirely supported. I know some of you are looking at some of the other devices and trying them out. We're working continually to figure out which devices to bring to you next to make them compliant with physics. One important device to make gameplay is the volume device. The volume device is going to tell you when a physical object has entered it. Right here, you get two new events, on physics enter and on physics exit. And I'll demonstrate that right now with this crate right here. You can go ahead and write some verse to get the volume device. You can also reference your creative prop, and then you can take your volume device and get that prop entered event and subscribe it and call a function, physics volume enter in this case. So on physics volume enter, it will pass the creative prop that entered that volume. And then at that point, you can go ahead and do your gameplay. This is great for making like a soccer game. So now you know when a ball enters a goal. So I've got the game mode in progress. I'm gonna go ahead and just push this crate in, and you'll see my print statement in the upper left. There it is. Now I can track when objects enter and exit spaces. And like I mentioned, props are also compatible with devices. So if I push this into this D launcher here, off it goes. And I mentioned about constraints on the sign. Here's the slap juice sign. And that would just spin and spin and spin.
That's so cool.
Yeah, so that's physics in a nutshell. So at this point, I think I'm going to go ahead and hand it over to Noah so he can demonstrate building a game using physics.
Perfect.
Exactly.
Switch over here.
Right. So
We are good to go.
perfect. So what you see here is a golf course I built. That's just static meshes. It's not anything. And what I will do for now for the stream is I will build a mini golf mechanic that uses verse and the physics system to make it a cool mini game mechanic. So what we first have to do is we have to import the golf ball. So let me drag and drop the golf ball right here. I've downloaded it from Sketchfab, and you can just import the model right here. And now we have the model. There's one thing you have to change on this model to make it work. It's important. You have to remove the collision that's there before, and you have to add a sphere symbolized collision. So it's perfect for physics collision and all of that. And also make sure you don't have complex collision as simple and ticked, because that won't work with physics. So that's very, very important. So we have this golf ball right here. What we will do with it right now is create a prop. What we can do, we can either right click and then scripted action convert to prop, metal, for example, that works. There's also other way to do it, but that's the fastest way to make it a prop. So what we now have to do, we have to make sure the golf ball is the right size. I've done that already. I've resized the golf ball. In this case, it's a smaller mesh. But for you, you can just use the modeling mode, and over here you can bake transforms. So if you let me actually do that, for example, so everybody knows what I'm talking about. It's if you place your golf ball in the map, you can drag the size down. Let me do 0.1, for example, in this case. And so it's very, very small. But if I leave it as that won't work. You have to bake the transform to be a smaller size. So the mesh applies to that size. So that works. So now we have the golf ball and we have the right size. What we now have to do, we have to add the Fort Physics component. Oops. We have to add the Fort Physics component. That didn't work. Yeah. I have to compile the prop. So we have the Fort Physics component on the prop right now. We have to enable simulate physics, and we can override the mass. I did that for my prop, but you don't have to. It depends on how you want the ball to feel like when you're shooting it. And so for my blueprint I made, I set up a few settings. Let me go in here. I've changed the mass to 5 kilograms. That's just how it felt good, but that's changeable for everyone. So if there's a value that feels better for you, you can change it whatever you want. You have to make sure you enable the gravity. Also, you want to start it awake, in my case. And we set up some damping, so linear damping and angular damping, just for the wall to slow down after time, after it's moving, so it's not rolling infinitely. And also hit multiplier, we can just ignore that. We don't need it for this mechanic. Constraints, we also don't need that. For this case, I selected a preset for VFX and sounds, but you can leave it as none. It's just a cool upgrade.
So, it actually is a pretty good question, and I was almost going to bring it up while Jay was going. With things like mass or linear damping and angular dampening and things like that, a golf ball doesn't necessarily weigh 5 kilograms, right? So as a creator, how do you play with these numbers to try to like make sure that you're getting something that feels right and is accurate to physics, but also does what you want it to and still has like fun gameplay elements to it? Because not everything is exact 1-to-1 in games in the world, right? Like we kind of fudge quite a lot.
Yeah. So one of the things that humans are really good at generally is that we're very good at physics. We understand physics from the moment we're born. We understand that falling over hurts and that things fall. And so what we've done in physics is that the base gravity for all of our props is Earth gravity. It's 9.8 meters per second squared for anyone who cares. But how do you the whole idea behind physics is while we need to make physics realistic in the sense that people recognize it, understand what's going to happen, consistency is actually what your players are expecting, right? They're not necessarily looking for complete realism. They're looking for consistency, and they want delightful responses to everything they do. And that's what we wanted to enable in physics. So to answer your question, Dan, really it's about playing around. You said it in the question is play around with the numbers. Find what feels good for your game, because playing around is going to lead to good feel, and physics is going to lead. Our job is to make sure it's consistent and predictable. So then your players will have a lot of fun with it. And I think Noah's going to demonstrate that with this game, is that consistency is important for golf, for mini golf.
Yeah,
Sure.
yeah, that's great. That's absolutely great. And just for the audience, like a little thought exercise to do with that is, rationally with physics, everything has an equal and opposite reaction. But if you watch movies or play games and stuff like that, you might hit somebody and they might go flying. And there's no way that's how it would happen in real life, but it feels right? So you would have to tweak the gravity and the physics and the force multiplier and stuff like that to kind of achieve what feels right, while also trying to stay grounded. Or I love consistency. Consistent is a great way to do it. It feels consistent to the rules of the world that you're in.
Right. Consistency is the most fun because we're not necessarily always looking for realism. Sometimes when you're playing a racing game, you want realism. And sometimes when you're playing a racing game, you don't want realism. You want wild, crazy, wacky fun. And the system wants to be able to support both.
Perfect.
Exactly. You can just change the kilogram, for example, in this case, and it's different gameplay completely. So what I did in this prop too is add a Niagara system. This is for a trail. It's not necessarily needed for the mechanic, but it just makes it feel better when you shoot the ball. So what it looks like if I place down the Niagara system in this case is it's just a trail that the ball will follow, that will follow the ball when it's moving. So right now I have a grid on, so it's not looking like that great. But yeah, it's just a cool trail I added. It's just a Niagara system that has a default ribbon material on it and just default settings overall on the Niagara system. And that's just for polishing. So what we did right now is just set up the golf ball itself. In my case, I've already built the golf courses. In your case, you would have to build that yourself. These are also like Sketchfab models. So if you want to check them out, search mini golf or something, that you will find them for sure. And so what we now have to do, we have to add the verse logic. In my case, I already prepared all of the scripts. It's pretty heavy, a few verse devices, but it's not as complicated as it looks like at first. So what we first have here is a player manager. This player manager is there to manage all the players joining and leaving the game. In my case, I'm using team member spawned event from the team settings and inventory device because it's more reliable than play space player joined event in my case. But you can also, for example, use the player added event in this case. That works too, but in my case, I use that. And I do create a custom player map for each player. And this custom player has a few parameters in there. For example, it stores the player itself, it stores the fort chart of the player, it stores a ID. Every player has a unique ID, and the IDs are generated at runtime, so you just have to specify the size, the amount of players in the map, and then it will generate the IDs for you. What these IDs are for is for identifying what is your golf ball, and also some other stuff in the golf manager right here. And this golf manager is basically the main manager of the golf mechanic. It has the golf settings class, which is just a few settings for the golf device. It has a respawn delay, so when your ball gets out of bounds, that's the delay, in this case 2 seconds. And also if start new next course delay is 1.5 seconds, you can just modify these in the verse device directly. And these are these two in the device. And also we have a ball per player. So currently we don't have the tools to apply a camera at runtime on the prop. So what I have to do is I have to create a ball in-game already in the editor, and I have to set the focus target overrides to the ball prop. So it's always looking at the ball itself. That's important because else you wouldn't follow the ball with the camera movement. So in this case, it's Orbit's camera device. What I also have right here is the golf ball itself, but I also have another sphere that's a golf ball, but I've inverted the faces of the golf ball. So what I did, I can show you. I placed the golf ball itself in the map. Let me make a duplicate of it so I'm not overwriting the old one. And this static mesh is the same golf ball as the other static mesh we imported. But what I will have to do is go to the modeling mode, and I will change the faces of the mesh. So I'll go to polygroup edit. I will select only the faces of the mesh and select all. And I will flip the faces. And I want to recalculate normals because else there would be weird shadow issues. You don't want that. And if you apply that to the mesh, it will flip the faces of the mesh and recalculate it. And then you will have a turnaround golf ball, so you can use it for this case, for this barrier that I had to do right here, so that the golf ball doesn't roll out of the field where they're located in their idle state where they're not used for players. Then I also use a D-launcher device. In this case, I scaled the D-launcher down a lot, so 0.01 in this case, just so it's not as big and annoying if there's other players playing also. And I've set up a few D-launcher devices that I've attached to a normal blueprint prop. So I've just right-click blueprint class, and then blueprint prop, and then BP underscore empty 2 in this case, because I've also already created one. And it's just an empty blueprint. It's just for teleporting and moving the D-launcher, because we don't have that in the Verse API right now. So this is the offset that the ball has to the launcher when I teleport it. So for example, when I take this right here and I just duplicate it and I select the golf ball and I copy its transform and I select this. You see, when you teleport it, it's like directly behind the ball, so it bounces in the direction. What I'm also doing in reverse, so it's not always going in the same direction, is I get the player rotation. I'm doing that in the shoot ball mechanic. I'm getting the forward rotation, so agent.getForward.getTransform.rotation. We currently don't have view rotation, so I'm using forward rotation, but both would work if view rotation works too. With view rotation, for example, you could also aim up and down. In this case, you can't do that, so keep that in mind. And this case, this is rotating the empty prop so that it is aiming the ball in the correct direction you want the ball to shoot at. This is very important because else the main mechanic of the mini golf mechanic wouldn't work. What I also have in store in this case, I've pre-made a UI that is, if you look at here, you don't see anything. That is because I have a material parameter collection where I set a power strength. This material parameter collection I set up with a material I have here. It's a progress bar material. It's just pretty basic progress bar. There's a lot of tutorials for how to make progress bars. So if you want to watch that, there's a lot of cool tutorials on YouTube. And I've hooked up the value. For example, if I set it to 1 in this case, the progress bar will update and it's full scale, so it's fully loaded. But if I set it to 0.5, in this case, I have to save it and also reopen the widget blueprint, so because it's not updating, then it's only half loaded. So that's what I'm using for aiming and also loading up the power of the shooting mechanic. So what we now have to do, we have to connect all of the different devices that are needed for the reverse devices. So we have the power up device in the UI manager. We have the golf manager, which has a array with a playable class that has a few settings and things I've set up. For example, the prop itself, the camera, the cinematic. The cinematic is there for setting the material parameter collection because we can't set it in verse yet. So that's just very simple animation and it's done in 3 seconds and then it's filling up the power strength. And so what we have to do is we have to connect all of these. Then also we have the launcher stages. The launcher stages, there's the prop itself in there for each stage, and also the time that is the maximum needed time for the holding of your mouse button to shoot the ball. So to shoot the ball, you have to just hold the mouse button and it's like the maximum of about 3 seconds, and then it's the full strength of the shooting. And I'm doing that using the input trigger device that has the shoot input. So in this case, it's this right here with the fire. And what I'm doing is I'm validating the press on shoot press. What that is doing is it's checking if the ball is stationary. That's a function I created in my physics utilities. A stationary prop is a prop that's not moving, that's like static, and it doesn't roll around the map or something, because you don't want to shoot the ball while it's still rolling, because then you would have issues if you teleport the D-launcher to the ball, and then it would be out of the reach of the ball if it's moving too fast. So I've set up a utility function is stationary, that it's just getting the prop and then just checking the no move velocity. In this case, I've set it to 15. You can manipulate this value to whatever feels right for your use case. And in this case, 15 worked great. It's just a get velocity function I create. I think I didn't create that. I think I saw that on UE snippets. It's basically just sleeping a set time, and it's getting the start location, the start time, and the end location at the end time. And it's calculating the distance, and with the time, it's calculating the velocity. Pretty simple, but pretty cool. and pretty useful for physics maps. What I also have in here is same prop, because creative props are not comparable right now. They're not unique, so you can't compare them. What I made here is just same prop function that is just checking the transform of each prop, so you can be sure that the prop that you're importing is the same as the other prop, because else you wouldn't be able to check that. I also have a await stationary. It's just an awaiter, so it pauses the code and then just waiting till the prop is stationary, and then it's going on. And what I also have in here is the audio manager. That is for different sound effects I added. I added a sound effect for golf into the hole. So if you hit the hole, and a golf hit sound, and a success sound if you hit the goal, and then you want to like have a cool celebration sound, for example. That's for that. So what we can do now is, if we set up all of these devices, we can set up the golf courses. For golf courses, I have start locations. So you want to make sure place a start location for each player. The start location are also just empty props, so blueprints without anything in there. And you want to place all of these start locations around the golf course and make sure, very important, for each player there has to be one starting location, so there's no issues when you have multiple players on your map. And also I have the hole volume. That's just a volume that's inside the golf hole. When you're reaching it, it will trigger events and call that you reach that. I also have a barrier, so just to make sure the golf ball isn't going out of bounds and just going to other golf course that I don't want to move it. Just the safety measurement. And I also have a out of bounds volume. This volume is just very big. You can place multiple in your map. It's just inside the golf manager itself. You can connect as many as you want. And if the golf ball is entering this volume, it will just reset and it will say, yo, the golf ball is out of bounds and you can't use it anymore. So all of the verse codes, by the way, I will provide later on the stream or as a link as a UE snippet. So you don't have to copy all of the scripts from the screen, so don't worry about that. You all will be able to use the script. So what I will now do is launch into the session. I will change my screen share, and then we will go into in-game and look how the mechanic feels like and how it looks like.
Perfect. That was a great demo for setting this kind of thing up. And I selfishly just kind of love the idea of using a mini golf as like a demo or like a trial. It feels like a way that would be good for someone getting into this to go with, because you're not dealing with a ton of physics things, but you're dealing with enough to kind of get the groundwork, and then that could be expanded into something much larger as time goes on.
For
or
sure.
in future
So,
projects.
for example, for this case, I wrote down a few things you could do. You can expand the system. For example, you could add what I did also. You could add a post-processing effect, so the ball has a outline when you're not looking at it in the screen. There's cool tutorials for that. So UEFN outline, just search that. You will find cool tutorials for that. Also, you could do you could create your own point system or a custom scoreboard when you want to do like more polished, finished golf map. And also, we don't have a game loop right now. We don't really have that. You could for sure use these scripts, and then just make something very cool out of that. And also something very cool to maybe keep players engaged in the session, maybe add skins or something that the golf can unlock, like for example, colors changes or like hats or something that don't actually change the collision of the mesh, because that's important, because else there would be some issues. But yeah, there could be some pretty cool mechanics that you can add in this mechanic that
We just need a prop mover windmill.
Yeah. Yes.
For sure.
Which, by the way, the prop mover is a device that we upgraded in order to work with physics. We also added, while we were developing physics, we added a bunch of community asks for the prop mover, which included things like rotation and different modes for it. We also added the ability to use the prop mover itself as a pivot point. So you no longer have to like attach. You can now have a prop mover reference a prop and then rotate it about the prop mover itself to create things like swinging arms.
I love that.
Right. My game is ready.
All right.
All right, perfect. So we are in the session right now, and this is all the devices I placed. And let me just start the game. Let me make sure that the device is all of the devices are enabled because I've disabled them before. No, that seems fine. So if I start the game, we will transition into the golf ball directly. And I've set, sorry, for the demo purpose, I set the default value of the material parameter collection as a different value, not as 0, because that's important. You have to make sure that's 0 and not 0.5 as I said it before in the stream. So I will just push changes for that to make sure that works. Seconds.
And that's part of the process, right? Like as you're building all these things, you'll get to a point where it's like, all right, we're going to test it and see if it works. And you'll expect it to, or maybe you'll expect something not to work. And then you'll have to go like, oh yeah, wait. Oh, yeah, that's right. I did this. Or you'll get a completely different result. And you have to go back and go, okay, what in all these changes that I did has kind of got this result that I wasn't expecting.
That's one thing I've always loved about physics games is that even if you don't get the result you expect, it's still really entertaining.
And sometimes it's better, right? Sometimes you're like, all right, I think that if it did this, it'll be good. And then it gets in there and it does something crazy and you go, actually.
Play it fun.
Absolutely. And there's a few games I can even think of off the top of my head that have like even said like, hey, this was not how we originally planned this to be, but it was an exploit and we loved it, or it was a bug and we loved it, and now that's just the game now.
What we could do is maybe while we push changes, maybe I could ask a few questions, and if you want.
Sure.
Okay, yeah. So I have a pretty cool question, and that's for all of us. What is the biggest challenge? What's your favorite physics game, base game, and why?
For me, it is Kerbal Space Program. Being able to build your own rockets, it fulfills a childhood dream for me. And then being able to build large missions and have it all be physically based is just wonderful. And I love playing that game. I've literally thousands of hours in it.
That would be cool to recreate in UEFN.
Oh yeah.
It could be amazing. Okay, push changes through. So let's start the game. And there we are. So we are moving the golf ball camera, and the golf ball camera is focused on there and on the golf ball itself. And also I've added the outline, like I said, with a post-processing volume. So you see the golf ball even when your camera is not looking at it directly in the view angle. And so in this case, if I hold shoot, there will be a power meter that's loading up. And if I hit the hole, for example, then we would hear cool sounds, but we also hear like cool hit sounds that I added. And you can customize all of these sounds. So if you want to change that to different sounds, you can just do that and connect that to the diverse device. Yeah, and that's pretty much it. The golf mechanic is working, and you can create pretty cool maps with that mechanic, and it's pretty easy to set up, and you can customize it with sounds, with different meshes, with skins, all of that. So have fun and create something cool with that, for sure. There's cool different golf mechanics you could create with that. There's a ton of different cool things.
I want to see someone create a golf adventure game.
Ooh.
Sorry, Matthew, go ahead.
No, I was saying, yeah, the creativity here, like just the amount of creativity that you can kind of put into this sort of game is really only limited by your own creativity. Like it's really cool to have a game like this where it can be so flexible and and you can spin it off into so many different genres or maps and stuff without feeling stale. I think that's, you can have nearly, as long as the creator or developer puts their own fresh take or creative spin on a golf map, I don't think anybody would get bored of them. Which is cool. I think it's a really powerful feature here.
If anyone wants to go take a look, I did a talk at Unreal Fest this year in Orlando, And we talked about physics, the tool set, but also talked about physics gameplay. And speaking to what Matthew is talking about, I think that one of the powerful things is that as a game designer, you want to prescribe the solution and you have to have your players play towards that solution. But with physics, instead, you can create sort of the space and the toys and say, here's your goal, here's what you have, you figure it out. And that's what I mean by emergent gameplay, because at that point, you're leaving it up to your players to figure it out. And when they figure it out their way, they'll have a story to tell because they're going to tell their friends, like, oh, you did that? Like, well, no, I didn't do it that way. I did it this way. And they'll, for example, they'll say, yeah, I could do that hole in the par three. It's like, oh, I did it in eagle. How did you do that? Well, if you shoot the ball this way, it bounces off this thing, bounces off that thing, and then it falls right in the hole. And then, so when players can tackle it their way, they're more immersed in your game. They're more involved in your game, and they want to keep coming back for more. That's what I mean by emergent gameplay. So when you make physics games, sort of take your hat off of trying to prescribe how it should be done and just give your players the toys and the tools they need to prescribe their own way forward.
Yeah,
Sure.
absolutely.
I've a few questions to the developers of the physics tool. So yeah, let's just start with the questions. Are there any plans to give us a verse API for physics?
Matthew?
Yes, there are plans. We cannot commit to timelines right now, but we are able to share, I think, what the intent will be behind these verse APIs. We intend to have creative props and fort characters be able to be physically influenced by verse APIs through a couple different APIs. We're going to have get and set linear velocity. We're going to be able to apply linear impulses. We're going to have get and set. Oh, I'm sorry. These are for both fort character and creative prop. For fort character and creative prop, we will also have get mass, and then finally for creative prop and fort character, we will have apply force, which is different if you're not familiar, because force is angular impulse is instantaneous, whereas force would be sort of integrated over time. So you'd be able to call add force on a verse loop or tick and be able to essentially have a much more gradual interaction with props or characters. And then for the prop, we will also have an additional get set angular velocity and apply angular impulse, and finally a add torque, which is sort of the rotational force API. So we have some very exciting things coming down the pipeline, but I can't necessarily commit to timelines. But yeah, we're excited to get this stuff in you guys' hands. So
that sounds very exciting.
Oh, I actually also want to add again that Unreal Fest talk. If everything that Matthew's talking about doesn't quite make sense, mass, torque, impulse, velocity, acceleration, physics talk I gave at Unreal Fest covers the basics of Newtonian physics and begins to demystify it. It can be a little confusing at times, and that's okay because they're kind of interesting concepts. So I recommend you go watch the talk and then start talking amongst yourselves or ask us questions about how does this stuff work, because it's important to understand what numbers you're tuning in order to make the game, because setting the velocity of something versus setting a force they're two different things. And once you understand them, it makes it a lot easier to make your games.
Oh, I forgot one other API for the creative props are get and set dynamic, which means that you'll be able to sort of freeze or stop physics simulation on creative props and then re-enable them dynamically. So you can kind of like freeze a prop midair and then on a trigger have it continue simulating, which is, I think that's gonna be quite powerful, but we'll see.
Very powerful.
Yeah,
sure. So question that leads into that a bit. When will we get physics in SceneGraph? Because that verse API might also include some SceneGraph elements, for example. Are there plans, and when will we get it?
Yeah, there's very much plans. I'm gonna not speak to the scene graph portion because that's for the scene graph team to talk about. But all the technology that you're using right now, the networking physics, the physics networking, I'm sorry, that is using underneath the hood, is we are all using the same underlying technology. So whenever scene graph is ready and they deliver their things, all of the physics should just work because we're the ones battle testing all of that now and making sure that all the network physics works, that our devices work with each other, that props function. Because one of the things that was really important as we went from experimental, if anyone saw, we went from experimental earlier this year to beta, and there was a bit of time there. And the reason why is because we sat down on that core technology layer and made sure that it worked. Because consistency is what I said earlier. Consistency is key. It's important. And if it wasn't consistent, we felt that your players would reject the games. They would say, no, this isn't good. I don't like this. It's not fun. And so that was our key thing. That's what left us with the extended experimental time. So I hope I kind of sort of answered your question. We're all working on the same base tech. So whenever the scene graph team is ready, they should be able to activate it and we'll go from there.
And that's something I'd like to kind of echo a little bit too, right? Is like, as devs of UEFN and a creator, you kind of have the same goals, right? Like you want players to come in and enjoy and have fun. And that's a lesson that you could absolutely and should absolutely take into anything you create in the future is you want people to jump into your islands and enjoy it. If you come in and they don't and they have issues or it's buggy or it's not fun or things like that, they might remember, oh, this person, created something and it wasn't that hot or whatever, and might not return. So that kind of consistency is great, and it's something you should also strive for too. That's not to say you can't have fun and explore and things like that, but definitely keep that in your mind as like something you want to strive for with them too, because it'll only benefit you in the future.
Okay, perfect. So let's move on with the next question. It is about vehicles. So according to the official physics documentation, vehicles are currently not supported by physics. And are there any plans to change that, to make vehicles compatible with physics?
There are plans, but the thing with vehicles is that we think the way forward is for scene graph to mature because we could sit down and we could upgrade the devices, right? We could spend a lot of time upgrading those devices and they would be opaque to you. You wouldn't be able to modify them or change them. That's one of the weaknesses of those devices right now. Instead, what we'd rather do is provide you with all the building blocks you need in order to build your own vehicles in the future. So we'd rather take the long road on this in order to do this sort of right, because we want to take the creation of vehicles like out of our hands and put it into all of yours. So just bear with us as we work towards this future goal because it'll be a lot better, I promise.
Sounds exciting.
In the
So
short term,
there's-
though, oh, sorry.
Yeah.
The short
No.
term, though, I don't know how many people have been playing with the baller. I can't claim it's perfect or that it won't crash your map, but internally, it's been pretty fun and kind of interesting what you can do with it because it's got that plunger on it, which actually, from what we tested, works with physical objects. You can like pull and pull around physical objects, which is kind of a fun one. So just
Sure.
just a little hint there. Maybe go check that out potentially.
We also had a question that is asked a lot, and it's about where is ragdolls? Where are
Where's
ragdolls?
Ragdoll? Oh, yes. We hear you, community. We hear you loud and clear that Ragdoll is something that you want. So we're taking that under advisement in our roadmap. I want to know what you want to do with it. So post to social media and post to the forums. What are you trying to build that requires it? Because physics is this cornucopia of features. We can go anywhere and do anything right now. We can add buoyancy, we can add constraints, we can add ragdoll, we can add vehicles, we can add volume forces, we can add more API. But we can't do everything all at once. So what is the most important to you? What is it that you're trying to build? And what is it that you cannot build? Because that's what our goal in the platform is. Our goal of the platform, like I said earlier, is the capacity for UEFN to make games. The types of games you want to make, the types of games that resonate with your players, and you know your players best. So tell us, what is it that you want to build so that we make sure we build the right features.
Okay, then I have another fun question. And it's also about the documentation, because the documentation says we're recommended to only use 50 physics props currently. Are there plans to optimize physics more, that we can maybe up that recommendation to maybe 100 or more props?
That's a complicated question. Yes, of course, we're going to be optimizing for physics because we want to be able to build large scale worlds for you where you can build physically based gameplay, however you see fit, and not have to not have to stress too much about. You want to focus on making your game. And so that's a reason why I said it's a complex question is if you make 50 balls, our simulation works really well. But if you go do some research in physics, you'll learn about things that like concave shapes. Imagine like a lens or a banana, that type of shape. Those shapes are more complicated to solve for collision. So if you have 50 sort of like bananas, that's going to be more expensive than 50 balls. So it's going to be on a per game basis. So we say 50 because that's just roughly a rule that we found that works really well. I've had a map with 200 and we were fine. And then you start doing a map with 2000 and it begins to kind of fall apart. But what we really didn't want to do is we didn't want to arbitrarily limit how many props there are. We wanted you to explore and then show us, hey, I made this map. I really want this to work, and it doesn't quite work as well. So we decided to take that route and just see what you all do and then begin optimizing from there versus trying to optimize against what we think is important.
And
Okay, sounds good.
And that's a good thing to kind of touch on too, especially if you're anybody who has like an art background or anything like that. If you're used to modeling something and you hear sphere, you think very expensive, very hard to calculate, sort of things like that. And you wouldn't know unless you delved into physics or did any sort of that programmatic things that like actually a sphere is quite simple to calculate in physics, which will seem counterintuitive to some creators and some devs jumping into UEFN. So definitely recommend playing around, but also like reading into the documentation and things like that to kind of understand that a little more. Because I'm just going to out myself. That's something I completely believed and was wrong about for a very long time. That I thought like, oh, I'm going to do a very simplified like 10-sided thing because I don't want to do a sphere. That's really a lot. It's not. It's very simple in math. An actual objective sphere is very simple.
And you saw that earlier when Noah was talking about setting up sphere collision, because I believe the order of operations of complexity. Matthew, call me on this. It's sphere, capsule, cylinder, box, and then after that it gets complicated.
It's so interesting how it's reversed, right? Because like the box
Yeah.
is the easiest thing to compute in geometry. It's like so simple. Well, I mean, a plane obviously is more than that, but like anything with 3 dimensions, it's like a box is super simple. But in physics, it's almost the inverse.
Yeah. So if you take one mesh that has 50,000 polys and you say, I want that to be the collision, you'll likely only get that one thing to work very well.
Yeah.
And that's for almost any game right now. Let's wait till we get quantum computing or something else.
Right around the corner.
For sure. So let's deep dive into the behind the scenes a bit. And I have a question that's pretty cool. What was the biggest challenge in completely remaking the Fortnite character to be physics based?
Well, one of the things is that the Fortnite character is what, 9 years old now at this point, and has a lot of development over the years of it to add everything, to tune everything, to make it feel the way it feels, to make it be the character that you all know and love. That takes a lot of time. A lot of time sitting there. We were talking earlier about making physics and playing it fun. That character has been played fun from the inception of Fortnite until now. When you enable physics, you enable a brand new physically based character. When I say brand new, it is brand new. It moves via a different way. It moves via forces. So we had to sit down and look at the character and replicate each and every mechanic, the walk, the run, the sprint, the jump. And that's why you have currently a limited set of movement modes, just because we're trying to catch up with the character as it existed. So we identified what is core to gameplay. What are the things you absolutely need? And we identify the ones that we have. The jumping, the moving. Obviously, all that was very important. Now we've heard feedback that other movement modes are extremely important, and we are looking into those. But it's not easy to catch up with it. But this is the future, and over time, I think we'll reach a reasonable place where all of you creators are very happy with it, we hope, because we've sunk a lot of time. I've spent much time just tuning that character so that it feels right.
Yeah. I was gonna say you don't have to go or like crazy in depth, but like what does that process look like? Like are you like
The jump,
picks
Jay. Talk
like
about the
Okay,
jump.
fine.
measuring distances of like between frames to try to ensure parity there,
Yes.
or like
So,
yeah.
okay, let's get into the dark details that you all forced me to do.
Let's
Okay,
do it.
the original Fortnite character, right? Can jump really high. If you look at it objectively, it could jump the height of itself effectively, right? That's like jumping 6 feet vertically. But it has to feel good. It has to go up and come down. And when you talk about game feel, you start tuning numbers. The number in Fortnite right now is approximately 2,700 centimeters per second squared, meaning it's 3 times Earth gravity. The Fortnite world is 3 times Earth gravity. We went with Earth gravity because as a human, I said before, you recognize how things should move. And when they don't, you go, that's weird. So the Fortnite character, if any of you were in the physics experimental, I put it out there with Earth gravity. But it needed to be able to jump the same height. And everyone said it feels like moon gravity. And I was like, well, that's funny because it's actually Earth gravity. That's what a character would look like if it jumped 7 feet in the air. But you all love that character. And I understand that was so important for your player acceptance. I tried it and we said, okay, we all collectively got together and we said, we need to increase the gravity. So the player character itself is 3 times Earth gravity. Physics objects are not. Physics objects are Earth gravity. So if anyone's done the Newton experiment in high school where you drop the feather and a hammer on the moon and they both fall at the same time, that is not true right now. The player character will fall faster because that is what you know from Fortnite. So then at that point, what I had is we wrote code that per frame said it's here, it's here, it's here, and dumped all the data, and I created tables. And then it gets even a little bit crazier because the Fortnite character, when you jump, the gravity applied to it changes over time. If anyone's ever built a 2D platformer, that's how Mario works. That's how every platformer's Crash Bandicoot works. When you jump, you generally fall down faster than you went up. And a Fortnite character does some of that. But a physically based character is parabolic. So what I had to do is sit there and tweak these numbers to be as close as they possibly could because you already build maps to a certain scale. That needs to work. You need to be able to clear and jump over objects, but it also needed to feel right. And so we'll continue to tweak that character, but we're trying not to change it. But we spent a lot of time to get it reasonably close. So yeah, I would have code that would run and I would have the Fortnite character jump and then the physics character jump and then track each one of them until the parabolas kind of matched. And I would
Yeah.
say that took weeks.
And this is a great example, just kind of echoing the point that we mentioned before, where it's like it's not always about like what is physically correct. It's about what feels right. Like
Yes.
I wish I could remember the math offhand. I knew it at one point, but like the gravity in Mario is ridiculous. Like your shins would explode if you had the same gravity in like the original Mario 1. But that felt good. That was where the movement felt fun to play with. And that's almost more important than like quote unquote realism.
Yes. Um, there's a GDC talk about, I think it was about how to make a good jump. I don't have it offhand, but yes. So it's the concept is you push the button and your character, it's a force and it jumps up. But then when you let go, what's a common thing in game development is when you let go, you actually increase the gravity. Because when the player lets go, they go, I want to land right there. So that they fall exactly on that spot. What I'd like to see in the scene graph world in the future is the ability for you to build your own novel physics behaviors. So as we invest in the character, try and make it feel good, give you what you need, I think the true solution in the future is to give you all the capabilities to do your own characters, your own physics behaviors your way for your game. I think that that's going to be the way to make sure that you have control, just like vehicles, over your physical worlds.
Yeah.
Okay, perfect. So yeah, we deep dived into the character creation. Now let's just overall, what was the biggest challenge in creating the physics system in UEFN?
I want to give this one over to Matthew because he spearheaded some of this stuff.
Yeah, I can chat about this a bit. one of the I'd say probably the most difficult challenge early on in Newton was adapting a game that never really considered physics in the proper sense to work with physics. And obviously that's very vague, and I'll get into it in a sec. But and even more specifically, like physics is physics in a single player game is drastically different than physics in a multiplayer game. Physics in a single player game, like I'm trying to think of, like, for instance, like a Breath of the Wild, right? Like you don't have multiplayer in Breath of the Wild, and because of that, you only have one spectator, which is you, the player, of the physics simulation. The moment you increase that number to even two, introduces a massive amount of challenges regarding synchronizing and making sure that the simulation is consistent across clients and the server, which is what we had to do for a lot of the devices that we reworked. And shout out the Nimble team. Like we did a lot of work on reworking many devices. The bouncers, D launcher, prop mover, crash pad, air vent. The biggest challenge really is just ultimately comes down to networking and the speed of light. If we didn't have if the speed of light were not what it is, or were faster or infinite or whatever, like if physics were different, then this would not be a problem. But unfortunately, due to latency and networking, we have to make serious we have to do some interesting compromises because of that. So one thing specifically is client prediction. The client has to guess essentially what the server is seeing in order to not have this massive delay as the server is updating the client as to what it's seeing. So for instance, if when we have like a ball rolling, like the client will predict that the ball will continue on this path until essentially the server notifies it that something has changed, or that the simulation has differed on the client and server. And then when that happens, this starts getting into some network physics realm. We have this concept of resimulation, of rollback resim, which Jay, the whole team kind of had to do a crash course on. I'm sure if you asked anybody on the Newton team what resimulation is, they could probably give you a pretty good answer. But essentially, the client has to roll back, has to look into the past and say, okay, where did things differ? Where did we go different than the server? And from there, we have to look at what the data the server sent us, and then resimulate the physics simulation up until the current frame where you are right now, in order to basically align things between the client and server. And when that inevitably leads to small differences, we have this concept of render interpolation, which will like gradually smooth things out over time. Like, so if your ball is like slightly different on client server, it'll kind of gently scooch the ball over into where the server sees it. But I'd say that's the biggest, like just networked physics, I think personally is the biggest challenge. It's something that is constantly throwing up roadblocks in our current, like, or just challenges. But I think we've done a pretty good job for the devices we have right now. And it's something that we're constantly, and that is the key, in my opinion, to making things feel good for you guys, right? For the developers, for the players. Like, these are the considerations we have to be thinking about to make a game feel smooth and look good and just be something that you guys want to play with and develop with and stuff. So hopefully I made sense there.
Yeah. But, I mean, if what it comes down to is, what was the thing that we needed to deliver most for you to make physics gameplay? And there were a lot of things. One of them was, there's things that you need to make physics, like the ability to add forces, collision, overlaps, and the ability to interact. Ultimately, we came down to interaction is the most important element, because without it, there's no physics. There's nothing simulating and rolling around. So interaction with the player, with being able to shoot things, use explosive weapons, use the pickaxe, push into them, use the devices that apply force. So the interaction was paramount. The one that we could get through easiest and earliest was the volume, the overlaps. That was very straightforward to do. So we did those two things first. So that, and then fixing the devices, everything Matthew's talking about, are fixing things such that, like you saw me push a crate earlier into a D launcher, or Noah is showing you where you're using a D launcher to move a ball. So if Noah clicks something, the D launcher pushes it. Matthew on his computer over here hasn't seen that yet. And let's say it's, half 250 milliseconds, a quarter of a second delay. So it's a quarter of a second to the server. Server says, yeah, I agree, Noah, that happened. And then now let me tell Matthew that happened. Matthew's now half a second behind from Noah. How do you keep all of that working? So the work that Matthew's talking about is saying, well, if we're say making a soccer game and the ball's moving, the server can make an assumption says, well, that ball's moving. I'm assuming it's going to keep moving. So I can go and tell Matthew's game, keep moving that ball. Because until someone does something to it, it's going to move. And then we use those little tricks to sort of smooth out the differences between it to make sure that all of you are playing the same game.
And I want to jump in there just very quickly too, because you might hear as a creator or a player and go 250 milliseconds, a quarter of a second. That's not a lot. But if you think about it, 60 frames a second is 16.6 milliseconds between frames. So you're talking quite a few frames where things are just not at all matching, and you have to compensate for that.
Yeah, that would be at 60 frames per second. With the scenario described, that'd be about 30 frames of it being missing. And if any of you play Rocket League, you'll see rollback resim actually in action. If you ever see your car kind of pop back a little bit real quick, that's an example of like rollback resim. That is the type of thing that you'll see in a network, and they do a lot of work to make sure it runs smoothly as well.
Yeah, there's plenty of stuff here with this that I'm that we still want to get to. I do have like a slight tangent that I just want to address a little bit, just because I know it's a question that I had when I was getting into all this stuff, and it deals with networking and physics, how it's so important here. Is like, well, why is it so hard to just sync these things? And again, we could be here for 6.5 hours just talking networking. It's ridiculous. But like, what is the most layman's thing we could say? It's data, right? Like it would take too much data to send to you every tick to calculate all these things. Like we're talking about how, oh, it'd be nice to have more than 50 physics objects. If we were sending the physics data every single frame to you, we'd be lucky if we get a couple, right? Like at that point, because it's just so expensive. Is there like an easier way or a better way to explain it than that, just for people?
I mean, sending a letter. How much can you put in a letter? How many letters can you put in a box? Okay. How big of a box? You get charged by that box. Eventually, you can't make that box big enough. You can't put it in a truck. Okay, so it's like the practicality of moving that stuff and distributing it to everybody. And when you send a letter, think of it as a letter because that takes time to go back and forth. So scale it up so you can think of it that way. And you're right, if we send to every frame. So we optimize this as best as we can, and we continue to optimize it so that you don't have to worry about it. We want to try to make it so you don't have to worry about it. Ultimately, you might have to. There are practical limits to what we want to do. But that's why we didn't put a limit on the number of objects, because we actually wanted to see what you were going to do. We don't know what the next Smash breakout hit is, because you're all going to make it, and you're going to tell us what the next one is. It might be some mini golf game with 100 players, and then we go, great. If that's what's breaking out, and Noah's making that game, we have to look at that and go, how do we go from 50 to 100, and that has to work seamlessly.
Yeah. Generally, with networking, you want to send as little data as possible. That's basically the point, right? Yep. So as many things as that they can, I don't want to call it cheating, but it is essentially cheating, or like interpret or interpolate or offset, like okay, now the client's going to do some of this calculation, so we don't have to worry about that sort of thing. That's a large part of why you might notice these things, and we have to do things like rollback and stuff like that, just to make sure that, I don't want to say under any internet, but like basically anybody is going to get a good experience, whether they're gigabit or,
Right. Yeah. It's like I was trying to, it's like if we could transmit information instantly,
Right.
there would be no issues here. But we have limitations due to living in our universe, or however you want to put it, that we can't do that. And so because of that, we have to make some trade-offs, and we have to be a little bit intelligent and crafty with how we allow players to hopefully interact in an environment where, we're talking about millisecond interactions instead of like waiting the round trip time to send data to a server and then back in order to confirm. So yeah, you're right.
Actually, there's an example that puts it, I think, hopefully succinctly. The pickaxe. Okay. The way Fortnite works is that the server decides everything, so that no one can cheat, right? We make sure that everything is level playing ground. So what happens is we tell when you hit something with a pickaxe, you don't actually hit it. We tell the server, the player wants to hit this. And the server goes, yeah, that thing's close enough. I agree. Client, you can go ahead and hit that. Right? If that took half a second, that would feel awful. Okay. So what happens instead is right when you click the button, the client goes, hey, server, they're hitting the button. I'm going to go ahead and make it look like they're hitting this. Okay. So I hit the crate begins to move, and the server goes, well, it should be here at this time. And then the client goes, I agree, it's right there. And they go, great, then we're in sync. And we go and let the client sort of like run that initial simulation, because that it has to feel good. It has to respond instantaneously. If it doesn't respond instantaneously, there's no point. It will just feel bad.
And that's a great example of why I'm excited, specifically me selfishly, for these tools, is because I know how difficult that can be, and you're supporting quite a lot already, and there's obviously more to come. But just the possibilities here, I'm already just like, this is great. Like I'm so excited. This is amazing. I can't wait to jump in and not only play with it myself, but also just seeing what the community makes with this, because you can plan a tool or a game mechanic or anything like that to be X, Y, and Z, and the community will take it from A all the way to Z, and they'll do things you'll never expect, and that's going to be good. I'm looking forward to that.
If anybody's like interested in this topic, like specifically like networked physics, or the character mover, right? There was a UEFS talk which was recorded and hopefully will be up on the Unreal Engine. I've been looking for it. It should be coming up soon. There should be a talk by one of our colleagues on this topic. So maybe keep an eye out for that if you're interested. I know I'll be watching it. So just a little tip, I guess, or a little heads up there.
Sounds good. Okay, let's move over to the next question. And that's actually a personal question. And it is, in your opinion, what is the single most missing UEFN physics feature or tool right now, and why?
I talked about earlier about how it's about simulation, overlaps, collisions, and the ability to apply forces. And really why you need all of those pieces together is because physics isn't about realism. It's about consistency and about responses to everything you do. So you could leverage systems so that everything in the world reacts, versus trying to script. Imagine if you had to script every single crate to do something. That would be a nightmare. So I think that it's the combination of all those things, so that you all can create your own novel physics behaviors. So that eventually, in the far future, in this beautiful scene graph world where we can make your own sort of like vehicles, your own behaviors on things, so that you can create golf balls that react in different ways. So you can create gravity wells easily yourselves, so that as you kick the ball around, it moves a certain way. So you can create a pinball machine. If anyone's ever played pinball machine, I played pinball machines with magnets in there, and that they use that to alter the course of the ball. So I think like that's one of the biggest missing pieces, is we need those four elements together, so that you can then in the scene graph world begin to build your own behaviors.
Talking about your own behaviors, what kind of physics game do you want to see built in UEFN?
Oh, can someone make Kerbal Space Program? I understand there's limitations now, but imagine a multiplayer space exploration game where you construct your own ships and launch them and fly them around the solar system. Yeah, I'd love to see that.
I
Wait, that sounds interesting.
personally, back that previous question about what my favorite physics, I would say like Portal 2. I would love to see an expansive just like a vast amount of Portal 2-esque maps where I can, it's just like I love the physics puzzle idea. And just, man, I just feel like if we can provide creators with the ability to do that well, like it's sort of similar to like the mini golf or putt putt example, like just like the bounds, the ceiling is endless there. I think like it's really just limited by your own creativity. I just feel like I want Portal 3 as bad as the next guy. But honestly, like I'll settle, not even settle. I'll take some Fortnite creator Portal games, man. Give them to me. I'll play them.
I'm gonna be selfish and throw another one in because I just talked about novel physics behaviors. I really would love. I'm gonna show my age here in the industry, but I'm proud of it. I would like, once we have the ability to do novel physics behaviors, I would like someone to rebuild a puzzle game like the Incredible Machine, where you give the player toys and you just say, it's like, put the ball in the hoop. Incredible Machine would do that. Just put the ball over there. How? I don't know. There's a bunch of toys, and there's no one solution. And I love that because that's where physics really shine. It's when players will do the things you don't expect. Because creators are going to do things we don't expect, but I hope creators, all of you, start to experience what it's like when players do things you don't expect.
This might be like a very expected answer, but I just want to see the coolest Rube Goldberg machines possible. Like I just want to see things that are just unbelievable, with just countless things hitting and falling and going down pipes and tubes and launching across the scene and stuff like that. It's not really like a game, right? It's more of just kind of an experience, but I love those. They're always fun.
We have somebody internally, and I'll shout him out. Joaquin has made a really cool marble race game, which is not quite in the same vein as a Rube Goldberg, but similar in the fact that it's sort of just like a spectator sport, sort of. It's really cool. And I think he has done Rube Goldberg machines as well in a simplified form. But yeah, like marble races and stuff like that. Like get some friendly kind of chill experiences like that, just watching a marble, I guess.
we hold physics internal jams and play tests to make sure we always use our own tools. That's something that we do at Epic all the time. And yeah, we spent a lot of time playing that marble race game.
I actually thought about the question too, and I think someone should make something like Peak, where you're climbing up a hill and there's like different obstacles, like a bridge or something. And of course, only when we are able to use ragdolls in this case, that would be cool to like have the player roll down the mountain or something. That could be like pretty cool gameplay with physics, I think.
Yeah, one of the things that's going to happen, Noah, is speaking of games like that, those social spaces. That's a very interesting space to be in, and once scene graph matures and itemization matures, there's going to be a convergence where all this technology is going to go together. So you'll be able to create items that have physical simulation, and that's going to be enabled. Those types of games where nothing was funnier than playing games like that when a med pack that I really need goes rolling down the hill and I'm chasing after it.
Yeah. And one of the benefits of it being in Fortnite is a lot of this stuff is kind of done for you, right? Like I don't know exactly what Peak was made in, what engine offhand, but they had to deal with replication and networking and stuff for all these physics things, where this is just kind of given to you now with these tools.
Yep. I mean, we've seen just an explosion in these types of games. And sorry, go ahead, Jay. I mean,
I was going to say, speaking of that, like, I would like the community to reach out to me because I looked at a lot of physics games because that's a hard problem, Dan. It is like doing physics games multiplayer is really, really hard. And so when a lot of people ask me like 50 objects, that's the limit. I was like, I think that's higher than most games I've ever seen played that have that. And we want to go higher because we want to be able to support the wild and crazy creations that you want to go for.
And that's one of the reasons why I love doing shows like this, right? Because it kind of helps demystify for people who aren't familiar with networking and processing physics and things like that. When you look at that, on paper as someone who's not familiar, it's like, well, that seems kind of low. But for like us, we're like, that's amazing, right? Like that's so cool. And the fact that we're going to get that number higher and things like that is even better, right? And it's good. And I like the community wants more, right? Because then you think, well, what could they do if they were given more, and things like that. Yeah,
For sure. Yeah, that's it for the questions.
perfect.
Does the chat have any questions about physics or anything that you want answered in the stream, maybe?
Yeah, we can go ahead and jump into some of the chat questions. I did want to verify, was there anything else that we wanted to demo? Was there any more things with that we were going to go ahead and show off, or are we good to jump into questions?
I think we're good to jump into questions unless there's something the community wants to see.
Can I ask Noah a question really quick?
Sure.
Sure.
Noah, what do you want to see out of physics? What would be your number one ask?
Scene graph physics.
Oh, okay. All right.
Okay.
All right.
All right.
Very good. Wonderful.
Yeah. I think that scene graph physics, there's so much potential for things you could do. Like, for example, I always thought about like making something like polybridge, where you're like building a bridge and then has something like a car has to move over the bridge and reach a goal. And I think with scene graph, that's something that could be possible in the with the system. Yeah, I think that's something that could be achievable with that. Currently, there's like not a lot of systems to, like, for example, fixate a point of a physics mesh that is not moving or something. That's pretty difficult right now. But if we had that, then something like that would be amazing.
Yeah. No, I noticed you didn't say ragdoll, so that'll be last on the list, I think. Yeah, dead last, right, Jay?
I just want to add something that Noah said, because I saw a question earlier about like certain specific items. When are those going to be supported? Scene graph is going to be the future in which and how we build games in Unreal Unreal UEFN and Fortnite, and the ability for you to define those behaviors yourself is going to be super important. So there's a huge backlog, cornucopia of things we could do. And it's like, do we go back and upgrade some of these things? Absolutely. There's some things that we need to update in order to facilitate building gameplay and making it easy, give it to you as a whole package that's good to go. But also, it'd be, I think the future is giving you the power to define it yourself. And so we're also focused on that problem. So when the question comes up of like, well, why aren't they supporting X, Y, or Z? It's because we probably are working on trying to give it a more robust way for you to do it. So it's like, are we going to support X item? It's like, well, wouldn't you want to be able to make your own item instead with physics? Wouldn't that be better? Because then you don't need us anymore to define that item for you. It's up to you. So we're trying to build a balance.
Combination with custom items then. Yeah, right now. Yeah, for sure. Yeah, that could be amazing. Something like, for example, you could make a rope or something that you can hold in your hand and then like attach to a point and then hold it and move up in the rope or something. That's like pretty futuristic thinking, but like that could be amazing, something to do.
One day, and then Matthew will solve all the networking required to make that happen.
I can't take any, honestly, Marcus Boberg, the networking guy, but I like it and I love being in the space. But yeah, hopefully we'll get there eventually.
Oh, we will.
Great. We can go ahead and jump into some of the questions here. We got a fair list. We might lightning round through a couple of these. First one is, will there be custom effects presets for physics?
Adding effects to the current props, you'll see that there are, in the physics component, there are a bunch of presets. We defined those presets for you because the way that they currently work in Fortnite is actually a little complicated. We had to bring in a lot of experts in to help us, and they were so thanks like Michael Camper and the team. They came in and they gave us a lot of the effects and the parameters in which they go off. And I think that the real answer to that, Dan, is going to be a scene graph thing, because let's say you have an effect. Let's say you have a boulder, it hits the ground, and you want it to make an effect, little dust cloud, little bit of particles. How fast does it need to fall or impact before it makes that effect? How about the bigger effect? How about the bigger effect? And so we could define it ourselves, but again, it may not serve you because it won't look right in your game, in the context of your game. It won't feel good. It won't be necessarily fun. So we've given some presets that I think work for most cases. They worked really hard on that, but I think it's scene graph is really going to give you the ability to define that for yourself. Because if you think about it, like think about that boulder when it hits the ground. What are you after? Velocity, or are you after how hard it hit before you play an effect? We don't know what that is. That's up to you.
Yeah. Great. Great. Is there a simple way to track which creative prop enters a volume, given that creative props are not comparable?
So even though creative props are not comparable, I think Noah, actually, you have
Yeah.
that code.
I showed a same prop function that's just comparing the transform from the two props, and then if it's the correct one, so it's the same one, then it succeeds.
Perfect. Perfect. Next one is it possible to apply impulse to props/characters through verse?
Not yet,
Not yet.
but soon. Maybe not soon. Yeah, I can't commit to timelines, but eventually, yes, that's the
I mean,
plan.
indirectly you
it would-
can.
Yes.
Indirectly. Okay.
Yes, Noah demonstrated excellent. Yeah,
Yeah.
it's not easy or clean. It's not as clean as using verse, but I mean, Noah, you did an excellent job of highlighting how you can do that right now. Yeah.
And that's a good thing to take note of too, right? Is like sometimes things aren't like inherently supported, but in a lot of instances there's ways you can go like, well, I know that this can do that and this works in this way, and you can kind of get like creative solutions to some problems.
UEFN developers are some of the best at getting around limitations. I feel like.
And we love them for it.
Yeah, we love
Mostly.
them for it. That's right.
Yeah. Will physics be allowed to be added to prefabs?
Directly, like, because Jay, I mean, maybe you can chat about, but I know where this is going. But
No, go ahead, Matt.
oh, so no, I mean, not yet, not right now. I mean,
Right.
you can't add physics to an entire prefab at once. So right now you have to do the painful process of going through each prop and manually adding the Fort physics component and then toggling whatever settings you want. We noticed, the team noticed that it was really rough to do that. We tried to debug an issue where when you added the Fort physics component to a prefab, it would delete some of the prop, like some of the props would just disappear from the level. And the bug testing for that was painful, like having to add it to every single prop. But I think we have a plan to have bulk add Fort physics components to props.
Let's just clarify. You're talking about adding them to blueprints props, not scene graph prefabs.
Right, not directly to the scene graph. Yeah, like the root scene graph. Yeah, actor. No, yeah, not.
Yeah, we're not looking at any of the scene graph physics stuff right now. What Matthew was talking about was the blueprints, adding it to multiple blueprints. Yes. We're looking into that workflow right now because there are issues with it, but we also want to enable developers to easily enable simulation on multiple objects at the same time.
Mm-hmm. Yep.
Okay.
Perfect. Will there be overlap events for physics objects that can tie into player hits? Is the way that's written.
Oh, I see what you're saying. Will there be able, like, if a ball gets pushed into a volume device, know who pushed it?
Maybe.
We're aware of that limitation, if that's what you're talking about.
Okay.
Yes. We'd like to address that in the future.
Maybe even something like the ball pushes the player because it's like heavy and it's rolling into your direction.
The ball pushing the player. I see.
Yeah.
In that, again, please tell us what you'd like to build, because right now, your ability to change the player is very limited. And with the scene graph in the future, we could create this new workflow in UEFN to allow you to maybe modify the player, but the player is very complex. It took us a very long time to get there. So I think that we need to come up with a good scene graph solution in the future to address that ability for you to tune the player the way you want it to be.
That's another one. Sorry, go ahead.
No, I know we have a device, and we're like, just let us know what you want to build. What do you want to change? What do you want to do? Because one of our engineers, I think it was one of the engineers, if you remember which one, Matthew added, like I think it was Felipe that added the ability so that the rocket launcher actually launches the player if you try to rocket jump.
Yes. Yeah.
Yes.
Yep.
So
Yeah.
everyone turn on physics and go rocket jump. It
Rocket
works.
jump.
Yeah, this is another example. I suspect that it's like one of those things that sounds simple, like, oh yeah, just make it so X can happen.
Yeah.
But when you're dealing with the player specific, I mean, this is true of a lot of things, but specifically the player in this instance, it's like, in theory, that's simple. In execution, it's quite a task.
Yes.
Yeah. Next one is 16 to 32 players and physics feasible. Any way to profile replication? Any options for local only physics? Kind of a three part.
And no to local only physics, because I don't think that makes necessarily sense because you're making multiplayer games.
Mm.
Any way to profile? Not currently at this time. 16 to 32, we have tested that. And it depends on the number of objects because the character is physically based. They count as a physical object. So if you were to dump in 100 physically based characters, they should work, but you might start to see a little bit of latency at times. But like I said, the order of operations of the most complex characters or objects are sphere, pill, cylinder, box. Well, the character technically their collision shapes are pills, correct, Matthew? So they're pretty simple there. Go build something. Go show us because we've built some of these things. We have thrown 16 players with 50 objects, and we were actually pleasantly surprised in our initial tests with how well it ran and how well the server stood up to it.
Yeah, this is a really good example of just like try it, right, and see if
Try
it
it
works.
and tell us.
And
Like
then,
it's not just try it; it's try it and tell us. Like what are you trying to build that's not possible? Because we want to make we want to strive to make anything possible.
Right. Is it possible to add a prop to float on water and move down a river, for example?
That would be adding capacity for buoyancy.
Right.
What do you want to build? I've actually had that request a couple of times, and I understand what those developers wanted to build. So again, we have a cornucopia of things that we could go and tackle right now at this time. So what do you want to build so we can try to figure out what is the thing we can do right now that enables you to build the most games?
I just thought about would be cool, maybe like a game where you control a boat or something in the water and something like that could be cool.
I mean,
Yeah,
oh, go ahead, Jay. Sorry.
No, absolutely. I was agreeing with Noah. Go ahead.
I was just saying, I mean, with the upcoming verse APIs, like you'll be able to add a force. And I'm not an expert on buoyancy, but I'm pretty sure there is a buoyant force, which is keeping the object up. So perhaps there is some creative way of, tuning this add force verse API to sort of simulate buoyancy in a way. But yeah, it's not like pure actual like buoyancy, so to speak.
That's for the
But something to maybe play around with eventually.
Right. Why can't devices have physics? They are technically props.
Because some of these devices were developed a long time ago. They were developed in Creative. When Creative was first incepted, they've been developed over the last few years. And some of them were built with the assumption that they were never going to move, unfortunately. So as you move them, you will see that they begin to malfunction in various ways. And in our testing, we found out that a lot of them malfunction more often than not. So we decided to holistically sort of disable the simulation of them until we can sort out what's going to be the best way to support them into the future. And then again, it sort of leads to the scene graph element because in scene, we have to solve that problem because in scene graph, technically everything can move if you mark it up as physics. So it's a hard problem to solve. And how many devices are there, Noah, at this point? Is it 280, something like that?
A lot.
There's a lot. So which ones do you need most right now? And give us your feedback. What are you trying to what would you do with it? Really, that's what we're trying to do. Because if we find a good use case, we take all that stuff into consideration. We're not trying to dictate what games you can make. You tell us.
Right. We're down to a couple questions here. If anybody in the chat has anything else that they would like to ask the team while we have them here, go ahead and throw those in real quick. We do have a couple, and then I actually have one myself, which will buy us some time for some additional questions. Any notes on what Iris is aiming to solve compared to the default replication system?
Matthew, do you want? I only know the cursory answer to this. Can you take this?
I may know just the cursory answer that you know, Jay.
Okay. So remember we talked about how much data you can send over the network and we try to optimize it. That's the goal of Iris. So the goal of Iris is to begin optimizing data that we send over the network. And then in that will help us optimize how many objects we can simulate, how much data we can synchronize between the client and the server. So there's several bottlenecks when it comes to physics. There is the client that you're on, your handheld device or your PC or your game console. Then there's the server. The server does have limitations. The servers are very powerful, but they do have limitations. But then the third part is the network connection, right? Who are your network connections? Are you playing over cellular? Are you playing over a hardline internet connection? Are you playing around the world? So Iris helps to solve, I believe, the network portion of it to optimize that. That's all I really know. I'd have to speak to the network engineers to get a more in-depth explanation.
Right, but that makes sense, right? Because like a lot of the limitations we've kind of mentioned up to here is that, right? So it's basically just trying to solve those limitations at a cursory. But yeah, we'll leave it to the team there to get any deeper into that. I have one just from myself here to ask. How do you recommend creators learn these tools? Is it reading docs? Is it looking online for maybe tutorials and things like that? Is it kind of just getting in there? I'm sure it's probably a combination of all three, but like personally, if somebody came up to you and was like, hey, great, I'm a creator, I want to use physics, I want to implement it in here, I have no idea where to start.
We have getting started documentation that our documentation teams put together. There's a golden path in there where you build an entire sort of soccer game from scratch. That'll show you all the basics. And then after that, start looking at the devices and approach with curiosity. Just play. Play with the tools, understand what their rules and limitations are. And then from that point, just play, develop, have fun. Iterate over and over and over. Find something ridiculous to do or entertaining to do that you find and share it and play test it and then publish it.
Matt, Noah, any additions to
that? I mean, for currently, there's like the problem that if you want to change, for example, values of the components, that you have to push changes completely. So that's like the only bummer when you're testing and trying arrow the different props. But without that, I would say just trying out different settings and like trying out different masses and things like that could be a good way to like get into it at first, so you like know what you're dealing with. And like, for example, the easiest way to know how it feels like is if you just place a prop at the component and just hit it with the pickaxe and just try out the different settings. I think that's the best way to start. And then if you want to go further and like make your own custom mechanics, then go into the documentation and look all of that. And yeah. And also, for example, if you want to do like advanced things, you will for sure need like some kind of verse setup. So that will be required to do any complex things of physics right now. But for the simple things, you can pretty much like set it up and place it in the editor and start a session and test it right away, I think.
And what actually, Dad, was kind of noticing, when I say play around, one of our engineers did this. It was really hilarious. Go take a plank, anything flat and long, enable physics on it, stand on it, and give yourself the pickaxe or a gun and shoot it. So it's not realistic, but technically the character's on top of this thing and we're applying a force using the gun. So that plank's going to move, but since it's physically based, you're on top of it. It's going to move with you. So he went surfing across the level, shooting this plank in order to get it to like move forward. And I'm like, someone's going to need to make a game out of this.
It's one of the reasons why I love physics so much, is that it can do so much, and oftentimes it can do things you don't even expect, right? Like,
yes.
A project I've been working on, I was using like a sphere to debug and it was just like a look at like wherever the line trace was going, it was the sphere would debug. And I just learned if I looked down and started jumping, I could just go into the heavens because I didn't turn the collisions off the sphere. It was just a debug thing. I didn't really need to think about it at the time. And it's just fun stuff like that. I always love those sorts of things. Great. Great. We have another question here. Does physics currently respect physical materials?
Currently, we do not have the concept of physical materials in the editor at this time. Yeah, it's one of those decisions that's because we need to make sure that we're future facing, and the future is going to be scene graph. So we need to start developing our solutions there in order to deliver them to you because like it's just like Verse. Verse was developed in order to create sort of a future facing way to create multiplayer games. And that's why Blueprint was sort of left behind because if you look at Verse and you learn Verse, you start to realize that right now, when you write Verse, it's server authoritative, which means you don't really handle right now the concept of server and client code. In Blueprint, you had to do that. You had to deal with replication and do it all yourself. But the way Verse was developed was that they didn't want the client to, they didn't want you to developer to worry about that. You just write the code once and it's done. And that's a better solution in the long term because if anyone here's built network multiplayer games, as we all kind of alluded to, they're hard. They get really hard. They get really difficult. And Verse abstracts that problem away from you completely.
Yeah. Yeah, that's great. Well, it's actually largely the questions that we have from chat. We'll give a little bit more time here for any other final questions to come in. But is there anything else you folks wanted to kind of touch on? Any things that we didn't already talk about here that you'd like to cover real quick while we have some time?
I think I have one point that is about the view rotation. There was a bug, and as far as I know, the fix for it is next update. Is that correct?
There's a fix coming.
Okay.
We're aware of the issue.
Perfect. Perfect. Jay, Matt, anything else? We've covered quite a lot here. We've covered quite a lot. So,
yeah. Really, what we thrive on is feedback from the community. We use our tools. We build things ourselves. We use them internally to make sure that they fulfill the promise that we've given to you. We sort of, in this case, in physics, we've prioritized player acceptance first. But Noah, we hear you with some of these workflows that need to be updated and addressed in order to make your development as frictionless as it can. So we want your feedback. We need your feedback. So please, when you go build things, don't suffer in silence. If there's an issue, a problem, or something that's lacking, something that's preventing you from building your dream game, please let us know. Because if you don't let us know, then we're going to prioritize what we think is important. And if that doesn't jive with what your livelihood is, what your passion is, what you want to develop, then you won't get it. So please go make stuff and let us know. Talk to us.
right.
We need it.
And a lot of folks will probably know the answer to this, but for maybe those who are new or don't know, what is the best way to provide that feedback?
I mean, the forums is something that is a direct line where we get feedback from the forums all the time. Our creator management, and our creator evangelists, they get that feedback and they make sure they get it to us. We have regular meetings where we go over the feedback from the community. Social media is another place where we go find it. Social media is a little harder because we have to go out and find it. So if you do the right hashtags, we'll get there and we'll see it. But the forums is like the guaranteed way to do it. And I know we have Discords. I would put Discord third just because when something's posted in Discord, it kind of scrolls away and it's gone forever. No one goes back into the history of Discord. And then if you ever see us at an event that you manage to attend, Unreal Fest or otherwise, please walk up to us. Just tell us what you're trying to do. Pull us aside and say, I'm trying to make this game. This is where I'm running into problems with. I always have a notepad with me. It's somewhere here on my desk. And I have that notepad and I write down everything that is told to me during these events. So there's lots of avenues. Just make sure you grab our ear and speak to us.
Squeaky wheel. Gets the grease.
Yeah.
Bob.
Perfect. Well, I think that's about it again, unless there's any last minute things you folks wanted to cover, with that, thank you all for coming on and showing this off. Noah, thanks for the demo. Jay, thanks for the demo. That was really cool. I while watching, I know for you, Noah, there was certainly troubleshooting and things like that that made that demo look so easy, but I was still just aghast by like just how simple it was and how it just kind of largely worked without having to go too crazy with like systems on systems or like pages and pages and pages of verse code. So it's cool. It was a great demo, and I want to jump in
Thanks.
now. Now I want to jump in. So perfect.
Awesome. Yes. Thank you very much, Noah, for coming
Yes.
on and asking the questions and demonstrating to the community how quickly you can put together a physics game.
For sure.
Yeah, and thank you folks for making cool physics tools for us and doing all the legwork of making tables with data of movement between frames to do this, because it's
I didn't do that. It's all physically based. I only had to collect the data and then make sure that our force values
Right.
would match. That's it.
Right.
And that's the beauty of it, is I don't have to prescribe it. I just say, when you hit spacebar, here's the force that's applied, and I let physics take over.
And
it does it.
And then when it's not right, tweak and then do it again. And then
tweak and do it
tweak
again.
and tweak and do it again.
I want to get more input.
If you ever
That's
see
how
Jay in an event, you can sneak up behind him and say "Fort Physics jumping," like a boogeyman. He'll go, "Oh!"
Yeah.
Just stares off into the distance like
weeks of this stuff.
yeah.
It was worth it. It was totally worth it.
Yeah. It just from a player and creator side, I think it was worth it, and I appreciate you folks for doing it. So that's gonna wrap up the this episode of Creating in Fortnite. Thank you folks all for coming in and showing off the cool stuff, and thank you to the viewers for coming in and asking your questions and being a part of the community and making really cool stuff. As Jay said, your feedback is invaluable for us in terms of what we make and create and address for you. So we appreciate you and for coming on, for giving all your feedback and making cool stuff. If you were coming in late or missed part of the show, don't worry, we have all of our streams that are posted in VOD format on YouTube and Twitch, so you can go back and scrub through and rewatch the demo or catch any parts that you missed. You can also keep up with the latest news, shoutouts, and other cool information on our socials at FN Create. And if you haven't already, as Jay was talking about, come to the EDC, the Epic Developer Community, where you can view documentation, tutorials, from both the community and staff alike, and visit the forums to provide all of the lovely and kind feedback. Please be kind for us. But with that, that's all we have. Again, folks, thank you so much for coming on and demoing for us. And we will catch you all in the next Creating in Fortnite.
All right. Thanks, everyone.